Okay, guys, so now we're going to do isomers and naming hydrocarbons. You started naming some of your hydrocarbons already, but I'm going to make it a little more difficult. And I hope that you kind of stopped and let yourself kind of digest what we were talking about last time, because it will be important, because I'm about to build on that now. So back to our page 5. So you had your page 5 all filled up to there. As a little review, just verbally, remember alkanes and an ane, alkenes and an ene, alkynes and an yne, and you want to make sure table P is going to tell you how many carbons you have by that prefix, and the suffix tells you if it has single bonds or double bonds. So we're going to kind of use that. So let's start here with our alkyl groups. Now, alkyl groups are actually a little bit special, and they have one less hydrogen than the corresponding alkane. So, for example, you're going to think about methane. So, methane, C1H, I think ane is going to be CnH2n plus 2, so H4. And I have to have one less hydrogen, so methyl is CH3. So methyl would be CH3. So alkyl groups, I'm going to have a YL ending. That's going to mean that I'm just like my alkane, only I have one less H. So for example, if I look here, it says I have 2-methylbutane, which is an isomer of pentane. Well, we're going to talk about isomers soon here. So let's see why they call it 2-methylbutane. Well, I always want to look at how many things I can touch without picking up my pencil. So I can touch 4 across right here, but I leave this guy out. So that means, well, then I'm going to name my chain. So I had 1, 2, 3, 4 carbons, so that's where my butane came from, the 4. Ane came from the fact that they have single bonds. And that 2-methyl, well, that methyl is telling me about that group right there. And the 2 tells me its location. So whenever you make a chain, now this will be important, you're going to number it. You're always going to number it so the special group, whatever special group it might be, comes off of the lowest numbered carbon. So I'm going to go 1, 2, 3, 4. Well, off of the second C is where I have my methyl group, so 2-methylbutane. This is where we start to get a little tricky. They say that it's an isomer of pentane. Line pent is 5, so C5, H, well, ane, so 5 times 2 is 10, plus 2 is 12. Pentane is C5H12. I can draw that with 5 C's. Ends in ane. Now here's where I'm going to tell you that you don't actually have to put your H's on. As long as you draw lines, you don't have to write all the H's in. So if I go like this, and I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 lines going to nowhere, a line to nowhere is an H. Let's make that. No, a line to nowhere is H. So that's important to kind of know. So an isomer, well, what's the same about these things? Let's kind of look, because we're going to fill in what an isomer is. So let's kind of compare so we can get these down here. Well, let's count up. Let's look at its molecular formula. This is C5H12. If I go back over here, there's 1, 2, 3, 4, 5 C's, so C5. And I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 lines to nowhere. So that means C5H12. They look different, but they're both C5H12. So an isomer is always going to have the same molecular formula. I should have the same number of every atom if I'm an isomer. But it looks different. So they're going to have a different arrangement. And because of that different arrangement, they're going to have different chemical and physical properties. So different arrangement, different chemical and physical properties. So isomers are the same thing that look different. So let's kind of look at two isomers here. Well, I've got, let's see, let's go my second one over here. Let's count how many carbons. 1, 2, 3, 4, 5, 6. 6 carbons, so C6. H, let's count our lines to nowhere. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. C6, H14. If I go to name that, that is called, let's say prefix for 6 is hex. They're all single bonds, so hexane would be this name. Okay, so I have to do an isomer. Now I have to do an isomer that's still got to be C6, H14. That still has to happen, but it can't look like that. So maybe I should try to kind of dump one of the C's off. So now I got 5 in a row. Well, if you think, well, could I just do this? That looks different because now there's going to be a bend in my chain. If I think about it, I can still touch all of these without picking up my pencil. Like that. Just like I can do over here. So that means this is not an isomer. But it would be an isomer if I put 5 in a row. And I moved it to an inside carbon. Let's see, do I still have 6 carbons? Yep, 1, 2, 3, 4, 5, 6. Let's put H's on so we satisfy everyone. 1, 2, 3, 4, 5, 6. This one just needs 1, 7, 8, 9, 10, 11, 12, 13, 14. Huh. I still have 14 H's. I still have 6 C's. But now let's see. So for my naming purposes, I can touch, let's see, and now I don't have to do it in a straight line either. I can do it in kind of a bendy line, but it's however many I could pick. So we'll go normal. I can touch all of these in a row. 1, 2, 3, 4, 5. I can touch 5 in a row. So that means pent is my 5 in a row. And they're all single bonds, so pentane. Well, I've got someone funny sitting here. So I want to say, okay, well, that is 1C. So meth, but it only has 3 H's on it, so it's not methane, it's methyl, and I gotta tell them where it is. Well, I should label my carbons. I could go 1, 2, 3, 4, 5. That works. I could also number it the other way, but it would not put this on the lowest number carbon. So it's on the second carbon, so 2-methylpentane is an isomer of hexane. So remember, isomers have to have the same number, but it has to look different. And I can tell if it's different if I can touch a different number of carbons. So I've actually been introducing this naming without actually telling you how to name. So just kind of introducing it. So this is my page 6. And so now let's actually put down our rules. So naming our organic chains. So the first step to naming is always going to be I have to find the longest chain. So think, how many carbons can I touch without picking up my finger? So for this example, skip the italics for a second. In this example, let's see, I can touch 1, 2, 3, 4. Let's see, probably not that. I can touch 1, 2, 3, 4, 5. Ooh, that's more than 4. Maybe I like that. I can touch 1, 2, 3, 4. No, I don't like that. That's 4. I'm thinking 5 is my best. 1, 2, 3, 4, 5. Okay. That leaves this hanging off. So that means, okay, go ahead and name the 5 chain because you know the longest chain is pent. So at this point, you know you're pent. Then it says, we should go back up here. If the chain is straight, it's the normal or N form. If you ever see an N in front of something, you won't have to use that just if you see it. So I've got my pen. Step 2 says name the alkyl groups. Well, again, here's my outlier. I did not touch that with my pen. So I have one thing hanging off. So methyl. And so I said, okay, I know I have that group hanging off. I don't have any other groups hanging off. And actually, I'm going to go back. I had already named my 5, and I knew they were single bonds. So my pentane is on there because they were single bonds. 3 says assign the alkyl group a number if necessary. Make it be on the lowest numbered carbon. So I want to name my chain. I am allowed to start here and go 1, 2, 3, 4, 5. Or I could go the other way and go, let me pick a different color so you can see. 1, 2, 3, 4, 5. In that case, no matter what, both of these are numbered 3. That is on the 3rd carbon. It does not matter what way I number my chain. So I say 3-methylpentane. This is the name of that drawing. But that would be one thing if you only ever had one. But sometimes I have more than one alkyl group. Then I have to use prefixes. Now I'm back to my other prefixes. So di means you have 2, tri means you have 3, tetra means you have 4. So let's look at an example. So if I go down to this first one, we'll call this number 1. We're going to first find our longest chain. Let's see, I think I can touch 5 in a row if I just go straight. I can touch 5 in a row if I bend it. Heck, let's bend it just to be fun. I can touch 5 in a row. So, okay. So, 1, 2, 3, 4, 5, pent. Single bonds, aim. So here's my pentane. Now I'm going to say, okay, what groups didn't I touch? I didn't touch this one. I didn't touch this one. Okay, well, I have 2 different groups that are made of 1 carbon. Well, 1 carbon is meth, so methyl, but I have 2 of those, so dimethyl. And I have to number my carbon. Now, I've got 2 options. I can start at the beginning and go 1, 2, 3, 4, 5. But that would put my methyl groups on the 3 and the 4. If I number it the other way, I can call this 1. That's 2, 3, 4, 5. Ooh, it is better to number it backwards. It gets those on lower numbered carbons. Because now I'd see it's on the 2nd carbon and it is on the 3rd carbon. So 2, 3, draw a little dash, dimethylpentane. 2, 3, dimethylpentane. All right, let's do this one. Let's see. Let's see how many can I touch without picking up my finger. 1, 2, 3, 4. No, I can actually get more if I do this. 1, 2, 3, 4, 5. So again, I've got a pentane. I've got 1 thing hanging off, methyl. And I have to do the location. No matter how I name it, I can go 1, 2, 3, 4, 5, or I can go 1, 2, 3, 4, 5. Either way, it's the same. It's going to end up on the 3. So this is 3-methylpentane. I also want to show you one more. Let's draw it down here. So to draw it down here, let's put 6 carbons going across. 1, 2, 3, 4, 5, 6. Off of, go over 1, 2, 3. Off of the third carbon, I want you to put 2 more C's. Fill everybody in with H's. Okay, let's try to find our longest chain. So you would use your finger, see how many you can touch. I think it's 6. I think that you could either do that and get 6, or I can do that and get 6. Doesn't really matter, so I'm going to use the regular one. So I also see I have this hanging off. I know I'm going to have to number my carbons. I could go 1, 2, 3, 4, 5, 6. That would put it on the 4th carbon. I don't think I like that. Let me put my H's back on. Because if I number it this way, 1, 2, 3, 4, 5, 6, it puts it on that 3rd carbon. So I like that. So if I go through, I say, okay, I have 6 in a row. So I say 6 with hex. There's single bond, so I say hexane. Well, I also know that now I have 2 C's that are hanging off it. Well, to say 2, I say F. So ethyl, and I got to say where it is. 3-ethylhexane. 3-ethylhexane. So if it's not, methyls are the most common, but if it's not, if it's more than 1, basically hanging off, that's okay. You just got to use a different prefix. So remember, as I'm doing these, if at any point you're wondering, where is she getting those names? Table P has your prefixes. Tells you by how many carbons you have what it is. Table Q tells you how many H's and how many C's I should have on it. So if you're not going to this table, again, you are going to be lost, so make sure you're going to this table. So I think I would really like to practice. So we're going to go to our packet page 16, and we're going to name some of these. Try these kind of with me. That'll be very important. So whenever I name them again, find your longest chain. Well, this first one goes straight. 1, 2, 3, 4. So I'm going to say 4. I go to table P. I say, on table P, 4, bute. So go bute. I see a triple bond in there. So YNE, butine. And remember how I told you before, just put it on the end so you wouldn't have to name it? Yeah, well, we didn't put it on the end this time. So now I need a location for that. So it rests on the, if I were to number it 1, 2, 3, 4, it rests between the 2 and 3. So you call it 2-butine. The second carbon starts a triple bond. Next one over. Let's see, I can actually touch all of those without picking up my pencil. So really, even though it doesn't look straight, it's straight. There's 1, 2, 3, 4, 5, 6, 7 carbons. So I say 7 with hex. I'm noticing all single bonds, so I'm going to go heptane. There's nothing hanging off, so I'm good. Next one, both in a row. Boom, I touched 2 of them. So I think 2, okay, think. I say 2 by saying F. I see single bonds. So I think. Nothing hanging on. Next one. See how many I can touch. 1, 2, 3, 4, 5. Can I get any more if I were to curve it? Nope. So I'm going to just keep the straight one because it's easier. And I'm going to say, okay, well, I got straight across 1, 2, 3, 4, 5. So pent is 5. Single bonds ain't ending, pentane, but that's hanging off. So there's one carbon, so meth, methyl, but I got to say the location. Now, you do not want to number it left to right here, because if you do that, 1, 2, 3, 4, that would end up on the 4th carbon. What if I go this way, 1, 2, 3, 4, 5? I'm putting it on the 2nd carbon. So I want to always number it so it's on the lowest number. Okay. How many do you think you can touch here? I think I could touch 3. I think that would leave these hanging off of it. So this actually leads me to, okay, I touched 3 in a row. Go to table P. How many is 3? It's prop. Single bonds, ane. So propane. I have 2 methyl groups that are all hanging off of the 2nd carbon. So here's how I say it. Remember, 2 is di. So dimethyl propane. They're both on the 2nd, so you go 2, but they're both there. So it seems redundant, but you go 2, 2, dimethyl propane. I'm going to do one more and let you do the last 2. So I have, let's see how many I can touch across. 1, 2, 3, 4, 5, 6. I've got a group hanging off here, a group hanging off here, a group hanging off here. So let's name my 6 across. So hex, ane because single bonds. I have 3 groups that all have 1 carbon. So 1 carbon is meth, so methyl. But I have 3 of them. I say 3 as trimethyl. And I also need to say their locations. So we should number them. 1, 2, 3, 4, 5, 6. So 2 of them are on the 2nd carbon. So 2, 2. The other one is on the 4th column or carbon. So 2, 2, 4 dash trimethylhexane. I want you to right now, we're going to go over them. When you come in, I want you to do these now. Do these now. See if you can do them, and we will talk about them when we're in class. Thanks, guys. Hope you're enjoying your break. Hope you're understanding this. Come in with questions for me on Tuesday, and I'll see you then. Thanks.